Looks like we're bringing folks in here. We'll let it populate for just a little bit as we're getting going. I know there's some people that will be pulled over, but we'll pause for just a second while the room continues to populate here. Oh, we've got Mike Hirschberg in here with us.
I was accidentally sent this link.
That's all right. We'll welcome you wherever you end up. All right. As people are starting to filter in, we'll in the future have a little bit of a, I know this opens right at 1 o'clock, so we'll look to adjust this a little bit in the future so we can get in. Looks like we've got our panelists here with Max, and then we'll pull over PK momentarily as we get started.
Thanks, guys. Hi.
All right, good there. Okay, people will continue to filter in, but we'll go ahead and get started here. So we have an exciting discussion set up this afternoon. We have, well, morning, depending on where you are. I'm going to start off with some of the partners that we have here on Agility Prime, 2 of our early joiners with Joby and Beta. We'll go to them. And then after that, we have a detailed discussion be led by Dana Jensen from the Air Force as we look to see what we might be able to do from our perspective of hardening our supply chain, making sure that we've got a resilient supply chain as we move this forward. He'll bring along with him several partners. We have PK from NASA, Max from AIA, and then we have the rest of our Agility Prime team here that will be participating in that. But before we get started with that, I'm going to start with a huge congratulations to Beta and to Joby. They have just over the last week completed what is the first phase of our Air Race to Certification. What this does, just as a reminder, this Air Race to Certification, we right now have 3 different areas of interest. The first area of interest is in this aircraft with a form factor 3 to 5 passenger. This is very much the classic model that we're looking at for the urban air mobility market. But as you know, there's a variety of different potential use cases that we are considering internal to the Air Force and that they've been considering as well on the commercial side. So in the Air Race to Certification, the step 1 is they've submitted. If you are interested in submitting to these AOIs or learning more about them, you can go to the agilityprime.com and then go over to Air Race, and you'll see all the associated documentation there that put them on a path to submit initially these artifacts describing here is the maturity of the vehicle that they have, the maturity of their business plan for certification, and path into commercial. As you know, what we in DoD are trying to do is to the maximum extent ensure that we are helping along this commercial path and not creating DoD specific requirements. The second step in this process is then if they've met the threshold of those baseline characteristics that we're looking for, then we went through and have done this initial discussion with the players, doing, in this case, a virtual tour of their facilities, being able to see some of the flight tests that is ongoing. And then the second part of the discussion is, okay, how can we help each other? How can we help these companies get on a path to reduce, in some ways, their technical risk, maybe the regulatory risk, and eventually the financial risk through use of different government resources, through participation in our airworthiness process, and eventually through early use cases that generate both data that hopefully is helpful to the FAA on their path to certification, as well as revenue that's helpful to these companies on their path to commercialization and early manufacturing. So those Beta and Joby have both made it through kind of those first 2 hurdles. And then this next path is a path where we start to look at collaborative prototyping, this request for prototype proposal that then kicks off a series. And this is not just a one-time request for prototype proposal, but if you look in the documents on agilityprime.com, it is an iterative approach that allows, it could be as simple as a flight through some of the test ranges. Maybe it's a wind tunnel testing. Maybe it's test expertise that could be provided with the professional testers that we have in the Department of Defense. Eventually, it could lead into the more detailed airworthiness discussions, as well as purchasing of assets, hardware or services or data in support of the planned fielding that we have in the Air Force for 2023. So with that, I want to hand it over briefly first to Cameron Guthrie of Beta. He's their head of government relations, and give him just a moment to kind of talk a little bit about his process and some of the path that he sees going forward. So Cameron, thanks so much to the Beta team, giving us an opportunity to take a virtual tour through there, hoping there's a chance to see some flying here in the near term, but love to get a little bit of your perspective and let you share a bit where your team is and where you're going.
Yes, sir. Well, thank you very much, Nate, and the Agility Prime team, all of you. You might hear a little Air Force air power demonstration in the background. We got some F-35s here. They're just taking off right at this time. But yeah, we're very excited about this win, and we've got a number of Air Force veterans and Marines and Army and Guardsmen working here at Beta, and we've looked at this, you know, the electric aircraft that we're producing as having military utility in the future, certainly, and so I'm very excited to get engaged early with the Air Force. We realize this is a team effort, and you've built an incredible team. We're looking forward to digging in and starting into execution. We read the senior leadership's vision loud and clear, and it makes perfect sense as taxpayers and Americans that we want to leverage innovation in the private sector and leverage small companies that may have been overwhelmed in the past by the acquisition process and things of that nature. And we've seen it already, just the responsiveness of your team and the ability to get to resources that we would never be able to access. And so we're very excited moving forward. And, you know, we recognize that, you know, it doesn't matter until it's flying in the field. So we really are focused on getting to that point where we can take these new technologies and produce simple, reliable, efficient machines that we put it, you know, the best of the latest technologies and ingenuity, and put them into the hands of the American airmen. And we know that their tactical ingenuity will put them to purposes that we haven't even considered. And we're super excited to begin that journey with your team.
Well, Cameron, thanks so much. It's exciting to have a chance to see the hardware that's coming together there. It's exciting, the milestones that you have upcoming soon. I really appreciate the work that your team has put in, and we're certainly looking forward to having this collaborative effort moving forward. Thanks so much to you and the whole Beta team there. Luke, over to you. Clearly, Joby is a major player in this. You have all announced a variety of very exciting milestones over the last few months in terms of funding rounds, in terms of releasing some of the early pictures of what the S4 looks like. Some great work that really being able to leverage what DIU has started. They've been fantastic partners with us as we start to make a transition, and really, I think has created a really nice model of what DIU is doing across the board. And now being able to help a little bit on the Air Force side, help bridge this valley of death, and hopefully be a help to the Joby team on your path to certification and near-term operations. So thanks a lot to your team. Over to you to give us a little bit of an outlook of things moving forward.
Yeah, thanks, Nate. And I think it goes without saying, similar to what Cameron said, is thanks to you and the team, you know, Dr. Roper, yourself, Natasha, Sterling, for making this all possible. I mean, I reflect back, I think 10 years ago, I don't think in my wildest dreams I would have, you know, thought about sitting on a Zoom call talking about electric aircraft and the future of urban air mobility and what's possible. So it's just amazing, and it's going to be really exciting to see what happens in the next 10 years, you know, let alone the next, you know, couple months here. You know, from the entire Joby family, we're all very excited that Agility Prime is moving the ball forward for eVTOL civil operations. and also that, the United States is in the lead bringing this new technology to life. And we know that with the requirement for new vehicle technology is going to pace the introduction of new forms of transportation. And it's amazing to think about the possibilities when we talk about, logistics and sustainment, medical evacuation, firefighting, civil and military disaster relief, and humanitarian relief in general. And I don't think we've yet uncovered, what is in the art of possible. These vehicles are, across the board in the industry are starting to fly. Joby's got a lot of, like you said, milestones that we've hit, and a lot more that we're making progress on a daily basis, and those will be released in time. So it's very exciting once we can unveil a little bit more what we're doing. I think the world will be really excited, and we're getting closer every day, and it's coming faster than what people think. So it's really exciting to see where the future is going to go. And just want to say huge thanks to not only the Air Force team, but like you mentioned, DIU being a huge proponent and really moving the ball forward, across the board, not just with electric aircraft, but everything from AI, machine learning, space. Really incredible to see what the DoD industry as a whole is doing, and just very excited for what the future is going to hold. So thank you very much, and look forward to continued engagement here.
Super. Thanks so much, Luke. Yeah, very, very exciting just to hear the very frequent updates of the great work that's happening there with Joby, and looking forward to that. The other thing that's really exciting about this is, both of these companies have done some impressive work just because of the innovation that they have. They're resident, working on really hard problems in the Department of, that have value to the Department of Defense, but working on a really hard problem that is the manufacturing challenges, the software challenges. It's postured these companies not only to do great things in the future aerospace market, but both of these companies are doing some very impressive work directly in support of COVID. And to be able to have those types of teams, to be able to build the teams that can reach into a supply chain and into manufacturing that has a diversity of uses across not only their primary thrust, but companies that are looking around in other parts of the world and saying, hey, we can help here. We've got expertise that could help there. Really impressive to see how they flexed over the last couple of months in support of COVID, and continuing to do that work. As we move forward, the other thing that's very impressive about these teams is how they have started to bring together a supply chain in order to take, in some cases, what requires a very specialized new capabilities and be able to operationalize those capabilities, take them to flight. As we look into this future, as we move to electric and see from the very core natural resources that are required to some very specific machining to a workforce that has to maybe think a little bit differently about how they integrate all these capabilities together. There's been a lot of energy we talked a bit about workforce last week, but we've also now started, want to put some focus this week in particular of how do we take what has happened really in these recent big successes. And again, you'll get to hear more about some of the work as these companies unveil the things they've been doing behind the scenes. How do we take the big successes that they've had at a small scale and now start to put this on a large scale to where we get this democratization of air travel in a way that makes it faster, less expensive for us to move both personnel. As you look in the time of COVID, how do we do this in a way that moves our supplies around to create more resilient logistics, both for civil and military use cases? And in order to do that effectively, to ensure that there is safety and security, a significant amount of work has to go into not just the OEMs who do the really hard work of doing the integration, but there's all those heroes in the background who are building the subcomponents and really making, the airplane, it's a sum of many different parts, and all of the work that happens in the background to ensure those parts can be built to safe and secure standards, to ensure those parts can be built in a way that's affordable so that we can eventually get to the types of scale and the types of public good that we expect out of this industry. So to focus on that topic this week, and to see how we, both in Agility Prime and with some of our fantastic partners across NASA, across industry, across the other interagency players, in some cases with some of the investment partnership, what we can do to ensure that is a resilient supply chain and a supply chain that can quickly scale. We have a team here who will be led by Dana Jensen from the Air Force Office of Commercial and Economic Analysis to help guide us through that discussion. So Dana, thanks for the great support that your team has provided to Agility Prime, the work that you guys have done also in support of COVID and the Air Force's capabilities in supporting the COVID effort. And thanks for being here today as we talk into this. So over to you.
Thanks a lot, Nate. I appreciate it. As he said, I'm from the Office of Commercial and Economic Analysis. It sits within the Air Force, but we do work for all the services. Our main MO is essentially to monitor and promote the private sector and the commercial and financial sectors work that may be dual use. So Agility Prime is obviously right in our wheelhouse. We tend to have capital markets expertise and an eye on markets that maybe the rest of DoD can lean on at times, and I think that's we're happy to help with Agility Prime. It's really an honor to be involved with this technology. It's the sort of thing that I think we'll all brag about to our grandkids at some point from a lazy boy chair somewhere. So yeah, really fascinating stuff. The supply chain itself, obviously, in eVTOL is a work in progress, right? And so we're excited at the fact that we can understand it from its birth, right? I was talking to one of the big prime contractors yesterday who has an amazingly complex supply chain, and they said they were envious of the fact that the eVTOL supply chain is at this point at least so understandable, or at least can be followed as it develops. And so that is true. It's not an easy task, but it's certainly an easier task than if you have 50 years of supplier relationships to dig through and a bunch of programs of record. What I'd like to do is introduce PK from NASA, because he has a very concise and very clear view of kind of the importance of understanding not just your supply chain itself, but also kind of the ecosystem as a whole. And that includes, the human capital, as Nate mentioned, right? Students, research labs, academia, mechanics, pilots, these things aren't going to fly if we can't support them and maintain them and operate fleets. So there's a whole aspect of that goes into the ecosystem. We won't be talking about that today. I'll be talking more today about specific kind of subcomponents or subsystems and who we see has indicated an interest in being involved or who already are. And part of the point here is that I would like to use this venue as a way to say, when we show later who we think is involved and you think you should be on there and you're not, please let us know. Or if you think we've mischaracterized where you think you fall in the supply chain, please let us know, because that's the whole point behind this is, we can accelerate our understanding of the supply chain through this mechanism. We explain why it's important on one hand, but we're also just as much soliciting information from you. So with that, I'll hand it over to PK if you want to do a screen share and show us what you have to do with supply chain. I think you might be muted, PK.
Okay, can you see my slides? I think you can see my face. Let me make sure that you can see my slides, and then off we go.
The slides were up briefly, and it looks like they're up again, PK, so we should be off to the races.
Okay, awesome, perfect. Thank you so much. Yeah, I'm really pleased to be here with you all, and thank you, Nate, for your leadership. I am on slide 1, assuming you all can see slide 1. That just shows the introductory charts, and thank you, Dana, for the introduction and this important topic that we are talking today. And we would love to help working with our close friends at DoD to the new winners, Beta and Joby, and obviously the entire ecosystem of the suppliers, because we really are after building a resilient supply chain that's going to scale to the operations that you are interested in. So let's talk about supply chain basics, the needs, the risk management, the opportunities, the collaboration, and the next step. So I'm on slide 2. Do you all see slide 2?
We've got you, PK.
Okay, good. I'm on slide 3. So why does supply chain matter? It really matters for the entire life cycle, right from the design. When you're trying to do prototyping, you need to have access to parts, whether it's uh, some kind of interesting molding type parts or some kind of electric propulsion motors, whatever have you. You need to have access to those parts, or sometimes you have to design and build them, but in a quick manner, because cycle time totally matters. Production rates matter towards the end, but in the beginning, you want to have fast turnaround for your prototype and production. Nate mentioned a little bit about the prototyping, and we really are keen on figuring out how quickly we can do prototyping. That's going to be one of the differentiators for us. So the basics of supply chain, this is somewhat textbook information. It consists of all parties involved, directly or indirectly fulfilling a need that we may have. And in terms of aerospace supply chain, it's an ecosystem of different tiers. One of the things we'll talk about is setting up a tiered system that doesn't exist for eVTOLs. Then manufacturers, suppliers, transporters, talent, skills, everything is included in the supply chain, and the coordination of all those activities. They all have to work together to make the production targets, as well as the cycle time issues and the resiliency and the quality that we all aspire to get. So if you just do a quick search on supply chain, right? So this is what you will find. These are the companies who are looking for aero supply chain experts, from Boeing to Zipline to Joby Aviation, Pratt Whitney, every one of them. There are close to 75,000 supply chain jobs out there. This tells you that there is something that we really need to change the ecosystem. It can't be that many jobs unfilled and yet expect that we will change the dynamics of manufacturing. So this is the reason why we are doing this. There's a huge opportunity, lots of interesting work. So what are the needs? I talked to many folks, many companies, the texts and calls and all that stuff, in terms of figuring out what the real needs are. And people are been asking for overmolding actuators. I just got another text this morning about someone wanting to know where to find motors, and I got another text saying that, hey, we might be interested in providing motors. So I'm doing a lot of one-to-one matchmaking or trying to hustle through this. But all that is telling you that as we need an ecosystem perspective that's going to scale for everybody, So we really need an entire supply chain from design to high volume manufacturing for different types of parts and different types of capabilities. I'm on slide 7 now. So typically you will see a OEM and the tier system. This is the typical tier system for aircraft. There's a very well established supply chain, and it's tiers for car industry as well. This kind of system doesn't exist for eVTOLs, and we need to build that. We need to build a supply chain network. We need to build the tiers so that they are the right tiers. And these tiers don't typically change from one company to another, but the somewhat standardization of the tiers is actually beneficial for the entire ecosystem, because you want to make sure that this tier system is robust and resilient. And if you don't have that, then you get into the trouble. If you customize it only for one particular model, you have scalability issues if the model changes. So let's also talk about MRO, maintenance repair overall. This is often neglected topic today, and it's somewhat afterthought. But if you're going to operate eVTOLs anywhere in the country, anywhere in the globe, you are going to need the part inventory. You're going to need the maintenance technicians and access to that. Just like your car industry, we have garages and we have maintenance and shops and things like that. It's a big industry. It's aftermarket. But it also says that aviation grade parts have a different unique value proposition. How do you maintain the authenticity of the parts? How do you maintain the authenticity of the maintenance technicians? How do you make sure that the vehicles don't sit on ground and have a much more downtime because we need to fix these things, or do preventive maintenance very quickly? So that's another area that needs to start to think about it right away. as we start to say, where am I going to operate it? Let's say if you're going to operate in Dallas or LA, we need to have the surrounding networks built. So in terms of outlook, of course, we are looking at many car companies coming in. There is some positive side to that. There's also a lot of lessons learned that they need to do. I'm working with some car companies trying to educate and to get them into the aviation grade market as to what kind of things they need to do. And FAA is very willing to help in this case as well. You know, how do you get production certificate? How do you get aviation grade manufacturing and such? So let's put all that stuff together. Now we'll just slide going to 11. The current risks, then, you know, you sort of look at all those things and say, what are the risks today? You know, we got limited or sole sources because of market is very saturated with dominant OEMs. And that's basically working for them for a lot of vertical integration, but that's creating a fragile supply in the market for others. So we need to open up the market. A good example of that is, so when one of the entities that produced the ventilator to fight the COVID issues, they basically created a ventilator with as fewer parts as possible, and they actually use the parts that are not from the current ventilator industry. So that they tapped into a totally new brand new supply chain and a network that did not overload the current system, right? So that created a very good, nice example of how you can actually go about thinking. And in this case, it may not be completely possible, but it may be intertwined with each other. But nonetheless, they reduce the risk. So that's sort of the idea of not depending on fragile supply chain and the market. We have capacity constrained supply market, which will not work to scale our marketplace for eVTOLs and urban air mobility. We have some foreign dependency, and that's not always healthy in some cases. In other cases, it's acceptable. So we had to relook at that as to where that's okay and where that's something that may not be necessary or not be prudent. Then we have diminishing manufacturing resources, material shortages. So figuring out the right materials right from the beginning and doing the assessment test to say, are we increasing the risk? If I scale, will I be able to scale on certain material, cobalt, you know, as an example? It doesn't have to be that. It could be many things like that in titanium, carbon fiber, whatever have you. You know, you take different materials that you have and say, will I be able to scale if I use that, continue to use that material? Gap in the human capital, and this is very important. We talked about the maintenance technicians issue, but we also need to have eVTOL, the workforce that people can design, modify, engineer these things, assemble and such, and product security at large. I'm on slide 12. So what are the recommendations? So we got to start building the entire new ecosystem right from the tiers. I'm also working on building a requirement for simulation that assesses the industrial capacity of the United States to get this thing done, and then do some trade-offs and parametric analysis to say, if I had to produce 20,000, do I have capacity? If I had to produce 120,000, if I had to produce, at what point I need a different game altogether, different manufacturers, different suppliers, or need to cultivate more capacity? Is there investment involved? Is the material available? We need to look at this as an industrial solution that is more systematic from system engineering model-based evaluation perspective. So what are the needs for future, and am I on the right path? You know, you don't have to have perfect solution right now, but we as NASA and DoD, we can start to think about it and set up the ecosystem that will allow you to scale. And that's something we should be reducing your risk. Take advantage of other manufacturing opportunities, heavy engineering, automobiles, such rebuilding and training these operators, suppliers to come into the eVTOL market. Get some regional manufacturing supply chain associations to partner with us and try to cultivate the opportunities that exist. I'm going to slide 13. Continuing on the recommendation, so I would like, you know, we are now doing requirements analysis phase for this electronic exchange platform that's baselines everything. Electronic exchange platform doesn't mean that you are sharing your secrets with other competitors. It all means is we are reducing your friction to access the and interact with the would-be suppliers from design to get the parts and get the ordering and understand who is production certificate, who is not, allow the new suppliers to join in an authenticated fashion. So anybody who is on that platform has some kind of quality benchmark met, So that allows you to reduce your, again, it goes back to that cycle time issue that we talked about. Training workforce, we talked a little bit about that, creating a tiered system, MRO network, existing MROs for general aviation and such that we might be able to encourage them to go into the new MROs network. In terms of immediate success, we would like to, I'm working on a bunch of suppliers to convert them or encourage them to come join eVTOLs, expanding the aero supplier base and manufacturers into this new area, educating and discussing opportunity space for many manufacturers and suppliers, creating this tiered system and ecosystem and electronic platform, simulation capability for long-term assessment, viability of competitiveness. All those things are going to be critical. So conclusion, last slide, building a supply base and supply chain base for aero, particularly for emerging vehicles, is critical. And that time, it takes time to build that. So right now is a good time to start building that supplier base. Supporting OEMs with supplier base and MROs. There are a couple of OEMs that have approached me. So I'm working with them and trying to help them figure out what is the most elegant way of scaling and getting even in the design, prototyping, and rapid manufacturing phase. Increasing production rates, which will be the critical need for future, and delivery as compared to current OEMs is going to be critical. Parts access, this electronic platform that I mentioned, and retooling and rebuilding our skills and talents so that we do have access to the local talent when you need it, and in this country. And that's my last slide. This is my email address. Feel free to reach out to me. We will be collaborating very actively with DoD and Nate and Dana and others that are involved. And this is very much a system solution, and we are looking forward to helping the ecosystem. Thank you, and back to you, Nate.
Super, thanks a lot, PK. I appreciate that. I'm curious, on the NASA side, can you talk at all kind of the historic work that NASA has done on the supply chain, maybe in others, and some lessons learned from some of those other examples, and what kind of piqued the interest there?
Yeah, so it's an area that NASA Aeronautics has traditionally not looked into, but this is something of my personal passion, and I have been driving this topic for last year or so, partly because I teach supply chain and operations management courses, and I've seen the need. I also have interacted with many other industry members, retail industry members, to see what the challenges are. And so this is a new area that we are embarking on inside NASA, and we have realized that part of NASA's charter is maintaining U.S. competitiveness and health of aerospace industry, and this is one of the areas that we are looking at it as a system solution. NASA is also doing more model-based engineering evaluation, migrating towards that, and part of that, this is a really good example of model-based evaluation for competitiveness and entire ecosystem. As we take more and more complex systems and engineering systems perspective, this is one topic that bubbles up that will be a barrier to scalability. So NASA is about scalability. This will be one of the big barriers if it's not addressed. And that's the reason why NASA and myself are very motivated to be in that mix.
Yeah, I mean, I think it's great. I think NASA has a unique position to kind of look a bit into the future of what that supply chain is. I think, as you're familiar, one of the strategies that we've been looking to do with the Air Force small business contracts is how do we be in a position where we've got really great research and development that's out there, What is the path to accelerate that research and development from eventually into production and making these small companies big companies? Now, clearly there are some companies that want to focus on doing research and development, but typically they want to do that to an end, that generates revenue and generates product. And I think both the path that NASA has in the approach to technology transition from NASA to FAA, some of the things that your previous boss, my current boss, Jay Dreyer, sees a similar path that we could do some good learning on how we can reach earlier into these companies and maybe help them realize faster where we have gaps and where there's really actually great opportunity to start to build that supply chain. There was a question that came across chat, how much is necessary that government do on this? And I think, under any view of government, government is seen as that stakeholder that can play kind of the long-term public good. And when you look at some of these cases where immediately there's research and development that may not be in a place to be commercialized, I think where the role that government plays is providing a little bit of that seed that does the research and development. And I think we've done a fantastic job of that in the past. I think the area where we all have recognized we can improve that is taking the millions of great ideas that are out there and turning them actually into product. And I think that's where, to answer that question, the government funding, I think, has always been a part of research and development. I think what we're doing here is we're shifting a little bit where that government funding goes in a way that kind of excites the movement over into the commercial by recognizing that there's this interim government market. We can help look at that government market. We can do that faster based on new approaches to data, based on new approaches to analytics, and see where that fits into a market space for us, so that we're really stretching the taxpayer dollars in a much more effective way that helps not just them, but then also helps kickstart the industry. So Dana, I don't know, I know you were working a couple of comm issues. I don't know if you're back on frequency with us or not.
I hope that I am.
You are. Got you loud and clear.
And I
now.
lost my background.
Oh, that's all right. So back over to you there, and PK, the fantastic discussion and super partnership. Really appreciate it.
Yeah, absolutely. Love to continue to work with you and support you, and thank you for your leadership, Dana and Nate. We're looking forward to it.
Yeah, I think it's pretty easy to see how NASA and Agility Prime are going to work hand in glove, right? I mean, we both understand the nature of the problem, and also it doesn't hurt that PK's out on the West Coast. So, he has the ability to reach out and, well, eventually we'll regain the ability to reach out and meet people out in the Silicon Valley area and maybe save us all some frequent flyer miles. Let me try to share my screen here. Okay. Can you guys see that?
We got it.
Good to go.
So you see my screen?
Affirm.
Okay. So, as Nate mentioned earlier, I'm from the Office of Commercial and Economic Analysis. We have an aviation portfolio. I mean, we look at all emerging tech. There's a portfolio that deals with digital technologies. There's a space portfolio. There's an advanced manufacturing portfolio. And, the kind of granddaddy of all those portfolios is the aviation portfolio, which I work in. But, eVTOL, I mean, the things I just named, right, cut across all of what eVTOL does. So I found myself, since I've been working on, eVTOL issues, that I'm working with all the portfolios at OSEA because there are technologies aplenty involved in these vehicles, and most of them are emerging or novel in some way. Let's see. Sorry, I'm not in presentation view here. It's just I didn't want to try to do it on the fly. So, along the same lines as what PK was saying, you have this kind of value chain. And, what I'm going to be talking about today is basically the far left of the value chain. In fact, you could even go further left than that to talk about raw materials, right? So, we have the OEMs in AOIs 1 through 3, who are the stars of the show for this first iteration of Agility Prime. But the intention is to start reaching down into the subsystems in future iterations and start fostering that growth, as PK was saying. Bolster kind of, I don't want to use the word commodity in a derogatory way, but we do want to commoditize some of these things and make them, if you think of it as kind of a catalog of known, trusted, tested, vetted components that future or aspiring OEMs can go to save them from having to do all that work in-house. And then, of course, as the ecosystem grows, you have the physical infrastructure in the airspace. In the airspace side of things, I think there's going to be a lot of crossover between the small UAS work that NASA is doing, particularly up in at Griffiths, formerly Griffiths Air Force Base in Rome, New York. We went up there late last year and looked at what they're doing, and they've got a pretty slick prototype small UAS traffic management system running up there, and that's going to involve a significant amount of hardware, ground-based radars and other systems, the remote ID systems that go on to or are going to go onto the drones are probably going to have some equivalent in the eVTOL space. So NASA is now transitioning that prototype over to FAA to further integrate it into the National Airspace System. But the good news here is we'll have a leg into the traffic management because of the small UAS, it seems. So that's one piece that might not be such a bottleneck, at least at the beginning, except maybe from a regulatory standpoint. From a hardware standpoint, we think we've got it more or less lit. Although the other thing is going to be testing in true urban environments, which Rome, New York is not. So they're starting to do testing in more urban areas. I think there was a session in Reno last year, and others are planned. I think there's one coming up in Texas. And then you've got the sort of fleet operations and support services, the kind of Part 135 stuff, and then the community acceptance, right? Not just acceptance, but also workforce considerations, education, and we need maintenance, we need pilots. What does a pilot for one of these things look like? That's an open question. How much training do they need? Is it fixed wing? Is it rotary? Is it commercial? Is it an airline transport ticket? I hope not, because that's going to really constrain our ability to put thousands of these things in the air. But again, so this is the whole picture. But I'm going to be talking primarily about the left-hand side of the spectrum. And you can see down below there's a kind of just the archetypical aircraft, right? It's got sensors built into it for sense and avoid, perhaps components that allow it to move toward autonomy at some point. We know that the value proposition of these vehicles goes way up when you free up that seat and maybe that slot on your payroll. The flight controls, the aerostructures, actuators. There are industries that produce aerostructures and actuators, but to some degree, they're a little too burly for these applications, and so they need to be kind of scaled down. There are automotive solutions for energy storage, for example, but they're not exactly optimized for weight the way that they should be for eVTOL. So, the fact that these vehicles live in this liminal space between helicopter and airplane and automobile it makes it tough to build out a supply chain. So with that, let me move one step further here. Okay, so this is the slide I imagine everybody's interested in. We identified, basically this is the byproduct of straw polling, right, among OEMs, among conference participants, among participants in Agility Prime. We went out and we tried to see who was doing what. Now, you'll see some of the big, established aerospace firms in there. And we put them in one bucket, right? Even though several of these firms do avionics and actuators and flight controls, right? So just for the sake of simplicity, we put them all in one, or we put them in one bucket. And any of you out there, if you're affiliated with any of these firms and you take issue with where you've been placed, as I said, just drop us a line and we will move you to where you think you should be. And if you're in one of these spaces and you're not there, you're not on our screen, please do let us know, and we'll have a conversation and put you on there, right? So this polling that we did yielded about 80 firms that are involved or want to be involved. Of those, about 20% were public companies. Sorry about that, I have a puppy in the background. Of those, about 20% were public companies. Now, the reason that we're differentiating public from private is because, from a policy standpoint, there may be a different approach to how to assist a public company that has access to the ability to float more shares, for example, as opposed to a private company that might be relying on venture capital. About 30% of them are private firms that don't report any of their financial data. 17% are private firms that have raised capital in the last year, and 24% are private firms that raised funding last between 12 and 18 months ago. Now, you may say, well, why do we care about that? Well, the reason we care is because if we want the supply chain as it exists now to get through the crisis, the COVID crisis, we need to keep a very close eye on firms that are going to maybe need to be raising money soon, right? And, as far as we know, liquidity in the private equity sector has been maintained, but venture money is starting to pull back, right? It's circling the wagons around its existing portfolio as opposed to reaching out to new firms. So we're keeping a close eye on the capital markets because these guys need enough runway to get them through the crisis. And this is another reason, please, as motivation, if you want to raise your hand and say we're doing one of these things, we'll keep you on our radar in terms of your liquidity position, in as much as you're willing to discuss it. So broadly speaking, when we look at the OEMs, several of the major OEMs are really, really highly vertically integrated, right? And it's because of the phenomenon I mentioned earlier, which is there is no real Goldilocks solution for some of these components, right? They're coming from other industries and they don't quite fit the bill. And so they're taking the work in-house. They're winding their own motors. A lot of interest in additive manufacturing, as you'd imagine, as you've got these kind of esoteric parts that need to be produced. And so you've got firms, it reminds me of early Ferrari production, right? Where they were making, like aluminum pellets would go in one end and a Ferrari comes out the other, right? They did everything in-house for quality control purposes, yes, but also of necessity in some cases, just because they couldn't source the parts that they were looking for via the traditional aerospace or automotive supply chain. So there's a big tendency toward that vertical integration, but at the same time, that might be, of necessity, but it's not what we want to have maybe in the long run. And that's the kind of to Nate and PK's points earlier, to the extent that we can establish a catalog of tested, trusted parts, it'll allow those to become commodities, get less expensive, and allow, new entrants into the market to be able to source those things without having to resort to, full-on vertical model. So there's a cohort of OEMs that are taking it on that way. There's another cohort that's saying, well, let's buy commercial off-the-shelf parts and modify them to suit our needs, and that's an effective strategy as well. And again, it's relying on the availability of those, but at least those are established kind of aerospace and automotive supply chain. So one of the things I'd like to just throw out there is, as we look at this build out of providers, of suppliers, if there are gaps, right? If you're an OEM and you have parts you would like to source and there are gaps, please do let us know, because in future iterations of Agility Prime, that's one of the things that we're going to try to address, right? We're going to say, okay, let's solidify, establish, nurture the component suppliers. And if there's something missing, let's see what we can do to get it off the ground, right? And that may not necessarily be through Agility Prime per se. It might be through SBIR funding or some other mechanism. But we certainly have an interest in understanding where you guys are having hard times. And, PK slides pointed out, sole source, that kind of fragility, it makes us all a little itchy. And of course, the other component of all this is, we would like as much of this laydown that we're seeing as possible to be domestic, right? And so this is a chance for us to kind of take control of that situation and move it in a direction that we like. Because quite frankly, when the small UAS industry blossomed years ago, we didn't do that. And we sort of lost control of the small UAS ecosystem. And I think there's a strong desire in government now to have that not happen again with eVTOL, which is, you know, such a transformative technology. So with that, Nate, I'll pass it back to you. Happy to answer any questions whenever it makes sense. Thanks.
Right now, actually, Dana, would be a really good time. We've got a number of questions, and I think it would be great to get those answered. So here is one for the overall group. Well, Colonel Diller, maybe you can answer this one. Is government funding necessary for companies in this space to succeed? I would like to get a government point of view, and then maybe Luke or Cameron, if you could give a perspective as an OEM, what did that look? How does that look?
Yeah, I'll talk to it just briefly a little bit as a follow-up from the last discussion, that I think it not necessarily, you know, the government takes a long-term view and funds those things that can become a public good that otherwise might not necessarily move forward. And I actually think, you know, I may defer a little bit to Max. I think he would have some additional thoughts on that from an industry association perspective, as either now, Max, or I think you'll probably address some of that in your discussion. And yeah, feel free to weigh in now before we give the formal. But Max is here obviously from AIA, and I think, you know, spends a lot of time thinking about what this intersection looks like between government and industry and where those collaborative efforts are. So, Max.
Yeah, absolutely. Thanks, Nate, and really appreciate you having me, and looking forward to giving a little more info on this in a few minutes. But I think the key thing we see is that no dollar amount or government program can create a supply chain. I think we've noticed, as I've just brought up in the small UAS industry, and this is brought up in the presentation I have, about $3.2 billion has been invested in the industry since 2008, and 2/3 of that have been invested domestically. And yet we don't still see a robust domestic small drone industry for that. And there's different programs we can look at, different paths we can do, but it needs to be ingrained from the DNA of our industry. And that starts with looking at kind of where the gaps are, as you mentioned, other things. So government money is part of it. It's not the entire solution, though. So I think it's investment from everything, whether it be a diverse workforce of the future, government programs, figuring out exactly where the gaps in the system are and how we fill those gaps. There's different levers we can pull for that, whether it be money, policy, programs, or working through partnerships with academia to ensure we have a trained workforce. So that's a long way of saying there's not one answer for it, but it's a piece of the puzzle.
Super, I think that's helpful. I know there's a question as well for PK, Natasha. PK, if you're up.
And PK, sorry, the next question was, who would build, control, and run the electronic parts and or supply chain system? Uh-oh. Is PK, are you on mute still, sir? Okay, we can move on to the next one. There's a question, Dana, maybe you can help answer. Why not build a sustainable circular supply chain?
Well, I have to admit my ignorance as to what exactly circular supply chain means in comparison to the kinds of things that we've been talking about. I certainly agree with the sustainable piece, but I'd have to plead ignorance about what the circular nature would imply for what we're up to. Happy to explore that, however.
Copy that, sir. Okay, so the next question. There is a push to stand up a rapid prototyping manufacturing center to support the AFWERX innovation centers and take great ideas from idea to design for manufacturing. Is NASA interested in partnering with this program?
Okay, sorry, I missed the previous question for some reason, but yeah, I definitely think we are interested in partnering with all of those items. And Natasha, I apologize for missing the first question, but the second answer to the second question is yes.
No, sir. In fact, if you're ready, the question was,
Yeah.
who would build, control, and run the electronic parts and/or supply chain system?
Yeah, it's a great question. So our goal at government is to reduce friction and reduce basically your risk. So we will build a prototype like we did for unmanned aircraft system traffic management, Nate mentioned, and we give it to literally to others to run. So this is not something government control kind of enterprise. This is more government initiated. We reduce the risk, we solve the problem, and we give it to the entity that is trusted to manage. So, for example, there are examples where the industry associations take that on and do a fair game. So there are possibilities like that. There are possibilities universities come together. There are possibilities industry associations come together and they manage that. But our goal is to not to hold on to that. Our goal is to build it, get it going, and start it. We have a couple of examples, like NASA built NPSS, numerical propulsion simulation system, and we reduce the risk. We showed how the APIs work, how people can connect, they can bring new ideas and technologies about propulsion, and then this was turned over to the industry to manage it. So that's my personal vision, is that we will do something like that, where it goes back to people who and organizations who benefit from it, not just NASA. There could be some government use cases, DoD use cases, FAA use cases, and others, but it needs to be managed by the entities who to benefit and not government only. Hopefully that addressed the answer.
Thank you, sir. The next question is, how companies can involve non-US persons into it, and what do you think about open source approach to aircraft design, which may dramatically reduce prices? And this is an open question to anyone that we have on the line today.
Well, this is Dana. We certainly have seen a lot of movement toward open source in the autonomous vehicle market. And, Berkeley has a consortium called Deep Drive. There's another one that's been set up by Baidu in China. And the catchphrase for them is, we want to become the Android of autonomous vehicles, right? And so, autonomous systems are moving along quickly along both tracks, right? The sort of open source and the more, I guess you'd call it kind of the Apple model. And so we're watching that really closely to kind of see where the pitfalls may be, because open source has shown to be pretty powerful. That said, let me go on mute for a second and take care of a little family issue.
No, that's fine, Dana. Was there anyone else that had input onto that? Okay. So then the next question that I see is, when will Agility Prime start engaging tier 1 suppliers, and what's the timeline for moving into this direction? Colonel Diller, I'm not sure if you could answer that, or if, again, that would be something that we need to stand by for Dana. I can hold off on that.
Yeah, Natasha, I mean, just as part of our contracting strategy, as you know, right now we have focused just based on bandwidth on the OEMs. And as Dana said, there may be opportunities to expand beyond that. Partly, it depends. That's the reason we have left the request for information open, and that gives an opportunity, if there's a lot of feedback that we're getting in communicating how we might be able to help with that supply chain. That's an area where we certainly look to go to. And I don't know, Nick, this may actually be a good opportunity for you to talk a little bit about some of the work that we're looking to do on the ecosystem. And this addresses, I think, a series of questions that are out there as well, to talk about how we're considering different options for this ecosystem development. So Nick, over to you to give a little bit of a preview of some of the things we're thinking about. We would certainly welcome feedback from the community on what that is in approach to that ecosystem, And then if you can, appreciate, send in some of those thoughts in on chat. As soon as Nick's done, we'll move over to Max, make sure we give him enough time, but we may circle back to this if there's time at the end, in case there's discussion on the chat of some of the ideas that Nick has come forward with, specifically to find different ways of supporting that broader ecosystem and the different tier one and really across the board on the supply chain, to include those interested in providing services, research institutes, universities as well. So Nick, over to you for an introduction.
Thank you very much, Colonel Diller, and good morning, good afternoon, everyone. So we fully understand, as you've seen from Dana and PK today, the supply chain and the understanding of just how intensive and immense the supply chain is for VTOL is just really extensive and huge. So Agility Prime is looking to help establish a collaborative ecosystem in the near term, building off of and working with NASA and OSEA and all of our other ecosystem partners to be able to engage today. While, like Colonel Diller said, our ability to engage right now with our bandwidth is kind of limited, but as the program grows and as we grow as an organization, being able to establish a collaborative platform for all of these ecosystem partners to build off of each other, to become more resilient and more effective, to start eating away at those barriers to innovation that have hampered the industry for a while. So our MVP and what Agility Prime is looking to develop and build off of was that showcase that we had on the last day of our launch. So a similar system where we have company profiles that are put together, creating a repository for all of the ecosystem partners, going all the way through the different tiers, and periodically running through challenges that direct and attack some of those specific problems that are facing the industry. And then in coordination with AFWERX and some of our other partners, and including joint components, being able to help allocate resources, whether industry and or government, to be able to address those problems acutely, while helping to build the rest of the ecosystem from the ground up, ensuring that there's going to be resources down the road and available long-term, whether that's academic, helping to push forth interest in STEM, and all the way through to the different tiers of suppliers, both on the OEM side as well as on the infrastructure side. So we're mirroring the same strategy that is currently being used and shown for the OEM and the aircraft, to help allocate and provide resources for them, and then we'll continue to do so as resources allow themselves to be able to do so down the road for the other elements of the ecosystem. We are definitely welcoming feedback and want to be able to be as useful as possible to the ecosystem as a whole. So if you have any recommendations on ways that Agility Prime could be able to engage with you guys, or add or provide value to your company or your organization, please let us know. And we'd be more than happy to take that under consideration, talk with you, engage, and look forward to working through and helping develop the ecosystem as a whole in the future. Colonel Diller, over to you.
Yeah, super. Thanks a lot, Nick. Like we said, still investigating different options there. We have received a lot of positive feedback from what we did on the Friday morning of our launch event. It was great to have a lot of participation in that. We look to potentially expand on that in order to, as Dana had spoken to, be able to bring those other players in. I know we have some additional questions. I do want to make sure that we give Max a good chance, though, to give us a perspective from the industry association. So we'll continue, keep the questions flowing in. If you have thoughts on the ecosystem and the approach there that Nick described, please send those in on the chat as well. And Max, let's go ahead and we'll take it over to you. Very much interested to hear from AIA and the different corporations that you represent, some places where we can continue to create this collaboration between government and industry. So thanks for joining us this afternoon.
Great, thanks so much, and hopefully everybody can see my screen now. I have a few slides to guide the discussion, and really appreciate, first and foremost, the Agility Prime team for having me today and asking us to participate. This is a topic that AIA has been thinking about for a very long time, and it's critical, as we all know, to the future of our industry. AIA and the Agility Prime team are working together on the common mission of making this new industry a part of people's daily lives. For those of you who don't know, Aerospace Industries Association, or AIA, is a Washington, D.C. trade association made up of over 300 members encompassing manufacturers, government service providers, and operators. We like to think that we take a mature mindset in our work to enable a high-level regulatory framework that will allow for these new technologies to operate within the existing aviation ecosystem. One of our biggest assets is our Supplier Management Council, which is made up of over 250 companies at all levels of the supply chain. This group comes together twice a year in person and really started thinking about this topic over a year ago when PK actually spoke to them about the challenges he was seeing at the time in the existing supply chain, much like he referred to a few minutes ago. And like almost everything, PK was 100% right and was one of the first people to start the conversations around this challenge. And ever since that conversation, our members have been very much committed to working with NASA, the DoD, and any other organization on how to best solve this challenge. So we go to the next slide. We really need to look at how we can leverage today's system for a stronger future. So as PK mentioned, and Dana as well, today's system relies on a historically tiered supply chain that consists of the aircraft manufacturer, or OEM, down to the supplier of the component level. All parts of this supply chain need to work together for our industry to succeed. Like any system, it has its upsides and its downsides. It's allowed companies to deliver more than 1,600 commercial aircraft, more than 950 single-piston aircraft planes annually, but it's also inflexible, which in part leads to a backlog that has been deemed acceptable in aviation. However, this system will face strain in the future as we introduce the new technologies at the projected numbers that we think we're going to see them in the future. So therefore, as we look at the existing system, we're going to add a new stress of these new technologies to it, and we haven't even begun that discussion around it yet. And I think PK and Dana both highlighted a lot of where those challenges are going to be faced. So in order for any of this to work, we need to ensure that we have a robust workforce of the future that's trained and educated on how to work with these platforms. What I think is really important, and I talked about a moment ago in the answer, is the supply chain is about more than just money and policies. It is a part of the fabric of our industry, and no single factor, albeit money or government policy, can create a new supply chain overnight. So next, just to look at a little bit of what I think a lot of people already know on this call, so I'll glance over quickly. As we look to imagine the future, we recognize that industry is fully invested in making these new technologies a reality. Over $1 billion each year in 2018 and 2019 was invested in urban air mobility or advanced air mobility now. And we've seen projections that highlight an even stronger industry investment in this technology. Since 2008, over $3.2 billion has been invested globally in unmanned aircraft systems or drones. And what's most exciting of that is about 2/3 of that money was invested in the United States. But unfortunately, we still don't have a robust UAS industry to show for it. On top of investment, we've also seen companies starting to show their designs to the world. The Vertical Flight Society has cataloged that there are over 270 different electric vertical takeoff and landing designs. The FAA has announced that there are at least 10 open certification projects and that many more companies are working with the FAA on their vehicle designs. NASA is doing some great research with the Advanced Air Mobility National Campaign, which will provide critical data to the FAA on items like airspace integration, infrastructure requirements, and more through their company partners, as well as their recently launched working groups. There's also their full advanced air mobility research portfolio that will look at things like CNSI, cybersecurity, spectrum requirements, and more. The Department of Defense, through Agility Prime, is working with both NASA and the FAA to not only help companies speed up the pace of technological development, but also working to ensure that the US is and continues to be the global leader in this technology. On top of their work with certification, the FAA is partnering with industry on critical items like vertiport standards and other topics that will shape the future of the industry. And lastly, the FCC, industry must work with the FCC to ensure that there's adequate spectrum available for these vehicles to safely navigate and operate. Industry and government are both making the necessary steps now to bring tens of billions of the economic output that's projected by 2040 to people's daily lives. As we mentioned, there's a lot of market studies out there that I think show how big this technology will be. One by Nexa Advisors estimates that about 1.3 billion passenger trips will happen in 74 cities around the world by 2040. These stats show that the technology is coming, so we must look beyond the vehicle at the ecosystem as a whole. So what is that role of government in the UAM future? How do we get to the future we're envisioning? The key word here is partnerships, including at the state and local level. This means investing now so that cities and states can plan ahead. It means adding urban air mobility and AAM infrastructure to the next surface transportation bill so that cities can study and plan for these infrastructure projects. It means working to expand the eligibility of existing loans and grants that have been around for years, but never allowed aviation to make use of the funding. For example, there's some programs at the Department of Energy that have allowed electric automobile vehicle manufacturers to take advantage of loans to do battery development technology. Those same loans could really benefit aviation uses, but they've not been available for aviation. And lastly, it means taking advantage of the electric vertical takeoff and landing mentioned in the Office of Management and Budget FY 2021 budget priorities that will allow for agencies to apply for research and development funds. But no matter what partnerships and policies we have, this future cannot be realized without a strong supply chain supporting the industry. It's the foundation of any effort to make this technology a part of people's daily lives. So that answer raises a major question of how do we get there? One simple example before we take a step back, and I'm not an engineer, so I can only do back of the envelope math, but if there are 1,000 vehicles operating in 20 different cities in the US, that means that there's 20,000 vehicles needing to operate. Even if we assume there are 10 manufacturers, that's still 2,000 vehicles per manufacturer. This is just a small example of the year-out projections we've seen for use rates, and I don't think it's a stretch to say that our current supply chain is not equipped for this to happen. So what do we need to get there? Before we look at the future, we must consider the present. The aviation supply chain has not changed much from the way Henry Ford envisioned it over 100 years ago. While there still may be more automation taking place, by and large, we still assemble parts and aircraft by hand. We must advance and modernize this process. It starts with 3 key areas that can help us grow and develop the urban air mobility supply chain. They are first, leveraging techniques from other industries, second, creating strengthening partnerships, and third, developing that future workforce. So to look at the leveraging techniques from other industries, it's critically important that we look outside of the traditional aviation sandbox for this. The automotive industry has long mass-produced vehicles at scale. In 2018 alone, domestic auto companies produced nearly 3 million vehicles. But automobiles and aircrafts are very different to manufacture and assemble. For example, the average Boeing 737 contains nearly 367,000 parts. The average car is about 30,000. The auto industry's manufacturing techniques won't single-handedly ramp up mass production of electric vertical and takeoff landing aircraft, but we should learn how we can best leverage their techniques while maintaining the required reliability and safety that comes with manufacturing and aviation. The good news is the automotive and aviation industry have a long history of working together. Auto companies like Honda and Mitsubishi manufacture aircraft engines today. And more recently, traditional auto companies like Hyundai have launched urban air mobility divisions, which promise to leverage the lessons learned from their auto manufacturing history at the anticipated scale of urban air mobility. But we just can't look at automobiles. We should look at any number of industries, from electronics to medical devices and more. Next, we need to look at increasing our use of automation. Other manufacturing techniques, such as automation, have not historically been used heavily in aviation due to the complexity of the task. That needs to change as we look towards the future. Next, we need to look at additive manufacturing. This technique is used to deliver simplified designs, reduce costs, and shorten lead times. Our industry has increasingly embraced this technique. For example, Bell Helicopter and GE have both used it successfully for years. And the global additive manufacturing aerospace market is projected to reach $3.2 billion by 2025. Next, we need to look at expanding aviation's use of new materials such as thermoplastics, shape memory alloys, and advanced composites. These are just 3 examples of materials that would all help ramp up production at scale. Secondly, we need to look at partnerships at all levels between industry and government. When we look at partnerships, we need to look at all possibilities between academia, industry, and government, because each of these 3 sectors have their own individual role to play. Building these partnerships has enabled our industry to thrive over the past 100 years. They allow for an open dialogue and information sharing, as well as each group to learn and shape the future of their work product. And they're also critical when we look at new technologies. One obvious example is taking place here. Conversations are critical to begin driving the discussion, and it's fantastic to see that the Agility Prime team is beginning their strong work in this area. NASA, as PK mentioned, has been looking at this for a long time, and earlier this year, they held a 2-day conference that looked at the future of the supply chain, where over 200 representatives of the aviation and other industries came together to start talking about how we can bring people into the aviation sandbox. PK, as he mentioned, is starting to work on the electronic exchange platforms for connecting the suppliers to the OEMs, as well as modeling the overall resiliency of the supply chain. And this is work that cannot be understated in its importance. AI is fully supportive of that work and enjoys partnering closely with PK on it. And these talks are just beginning, though, and we must continue to expand them. Next, we must work with government leaders to create regulations and pass legislation that allows for these aircraft to operate and establish the necessary infrastructure to support the aircraft. No single sector can create a supply chain overnight or in a decade. It will require building new partnerships between government and industry and strengthening old ones. Lastly, we need to look at the diverse and robust workforce of the future. As most of us know, the aviation industry is facing a shortage of workers, but these technologies are creating new jobs that need to be filled. Furthermore, we must work to retrain and retool the existing workforce to adapt to future conditions. We're changing the landscape of the job through new technologies. If you think about it, just 10 years ago, no one could dream of being a commercial drone pilot or drone traffic management architect because the job didn't exist. And our impact is only just beginning. These technologies are a new segment of the economy and will require different skill sets than ever before. We must work to inspire students as early as possible, getting them started in STEM activities in elementary school, not waiting until high school. And we must work with colleges and universities to ensure that they are teaching the skills necessary to allow incoming workers into our industry to succeed. Those of us here on this call are here for the birth of these technologies, but it'll be the next generation to ensure that they're a part of our everyday lives. As we go to the next slide, I wanted to focus a little bit on how Agility Prime can help. As been made very clear, Agility Prime leverages the government to bolster the commercial industry. And this has been an extremely strong partner to industry in the short time that Agility Prime has been announced. The US government has always been a strong partner to the industry. And like I said, this is no exception. Agility Prime has signaled to the world since its inception that the US is serious about being the world leader in this technology, and it's ready to put the full force of the federal government behind that effort. This is not only important as we look to establish and maintain global leadership in the space, but also as a demand signal for industry, venture capitalists, and others that the time to invest in building a robust supply chain is now. One example of how DoD can help is through creating programs like the Trusted Capital Marketplace initiative that launched last fall. This initiative looks to connect trusted sources of capital to trusted companies. It's a great way to connect industries together that meet the government seal of approval. But the program was designed to help with small UAS, and therefore it won't work for all facets of urban air mobility, advanced air mobility type missions. However, we need to look at any and all programs that we can create that will help bolster the supply chain. As we mentioned earlier, the supply chain is far more than any one policy or dollar investment, and that's why these conversations are so critical, and the work that Nick just mentioned and Dana mentioned, as well as PK, is critical to moving the industry forward. The DoD has had a long history of ensuring that our nation has a healthy supply chain. And industry is fully committed to working with the federal government to ensure that urban air and advanced air mobility is another example of this relationship. AIA firmly believes that this is the most exciting time in the aviation sector since the dawn of the jet age. Advanced air mobility is going to change the way in which goods move, services perform, and people connect. But that change won't happen without focusing our efforts on all facets of the ecosystem. And that means ensuring that we have a strong global supply chain to meet the demand that we are all hoping urban air and advanced air mobility brings to society. Thank you very much, and we'll turn it back to Nate for any questions.
Super. Max, thanks so much, and thanks for the partnership of AIA. I think it's important. It just brings a great perspective of bringing those different partners together there. I know, Natasha, there are several other items that have come through on chat. I want to address just a couple of things, and Max, maybe get some of your perspective on those as we're going along. There was some discussion about being able to look at some of the deeper supply chain, and maybe I'll both between Dana and Matt, but work that is being done really on the critical minerals and materials necessary. What do you kind of see in terms of the work that needs to be done there and some of the work that is being done there?
Dana, do you want to kick that one off?
Yeah, I mean, certainly, you know, the administration is cognizant of the issue with rare earth elements, and there is an executive order out there that provides some authority for DoD to go and start building out our capacity to mine and refine rare earths. And there's a question here talking about neodymium magnets, right, which are the permanent magnets that go into the high power motors that make eVTOL work. That market or the production of those magnets is almost exclusively in China. And so, you know, to turn off the faucet or the flow of those magnets would cripple our industry overnight. And so we really need to start thinking, down to the raw material level, right?
Hey, Dana, we can't hear you, guys. Are you muted by any chance?
Oh. No, I'm not muted.
Yeah, no, we can hear a lot.
Oh, okay. So yeah, I mean, it is, even with the vertically integrated firms, we still need to think about raw material, right? And the additive manufacturing requires specialized powders that are very difficult to produce. And where are those powders coming from, and what supplies do we have? That's definitely something we need to consider, and it's definitely something that we have authorities as DoD writ large to go start taking action on to build out other sources, whether they be in Canada or other places where the minerals actually exist. I mean, the fact that we have a rare earth problem isn't due to a lack of rare earth ore in the United States. It's due to a lack of refining capacity, or because we economically decided that it was more advantageous to do it overseas. And I think now we're reconsidering that decision. And so and that's going to play a big role in eVTOL, certainly. And I just want to take 1 second to thank Max. One of the things that I've discovered over the years is that industry associations are a fantastic place to start to understand technology. OSEA's got these technology portfolios that span the whole gamut, and the first phone call that I always recommend people make is to the industry associations. I know Mike Hirschberg, you're on here with the Vertical Flight Society, huge resource. The American Manufacturers Association, massive, long-standing associations with a wealth of data about who's doing what and how those industries evolve. And so we're always glad, I'm always heartened to see when we've plugged into those associations, because it means that the effort is maturing and headed in the right direction and stays grounded, right? Because the first thing we do in the Pentagon sometimes is try to figure out who else in the Pentagon is doing what we're doing. And that's a worthwhile thing, but it's also, I think, important to figure out, who in the industry is doing things, and those industry associations are pivotal in that role.
Yeah, absolutely. And we're glad and very excited about the great partnership that we've had so far in the short time of Agility Prime, and look forward to continuing and build it. As I mentioned before, I think PK would readily admit that he and I are texting or talking back and forth a lot on different areas with having to do with supply chain and other things. I think the role of the associations, obviously, is to do that and represent our members, and really appreciative of the great partnerships we've had. I think to answer the question a little more directly, I think that's a lot of the look of the Supplier Management Council that I mentioned earlier, which is about 250 of our members that look at supply chain issues. So they talk regularly and meet in person twice a year, and then we can kind of develop where those gaps in the system are, where we need to fill them, and what we need. So if there's a signal that insert random raw material is hard to get for this purpose, then we can then advocate on that behalf and bring it to, whether it be Dana's team, Colonel Diller's team, the FAA, Congress, whatever it is, to ensure that we can have access to that. So I think it's very much that partnership that you were talking about, where we can identify the needs along with our association partners, and then bring it to you all. So really can't say enough good things about those partnerships.
So if you talk briefly on a related subject, specifically to batteries and motors, what the state of that technology is, the state of that supply chain, and any expected deltas that you would see between what would be commercially used and what would be government. In my opinion, as we get to some of those, I think by and large, we're from an Agility Prime perspective, not seeing any major changes that what is commercially available would be what we would expect to use on the government side. From a supply chain perspective, where do you see those right now?
So speaking as an industry association, I obviously can't speak to the requirements of the military side. I can speak to what I see our members looking at. And I think if you look at them, the range is approximately about 150 miles right now at most. And obviously, as we continue to advance the technology, we'll continue to advance what that range is. I think it goes back a little bit as well to some of the things I mentioned about expanding eligibility to programs such as that the one that was being used for car batteries to aviation, as well as some other programs that are loans that companies can get and pay back over time to work on the rapid development and advancement of the technology. So it works very successfully in the auto industry, and I think could work very successfully here. Obviously, batteries are a challenge, and I think everyone would admit that, but the advances we've made in a very short period of time and the advances I think we envision continuing to make really are impressive and will continue to allow for more range, capacity, and more along those lines. So I think from our side, we're really excited about the batteries. I think we can do some things to kickstart that development and deployment of them, but I think it's really an opportunity for us to make some good headway on it.
One other related question, and I think this will have to be our last question, but this goes a little bit probably from the microelectronics perspective, but you can imagine it cutting across other technologies. The idea of being able to potentially leverage and bring to a path certification of those items that are used in high volume in the automotive industry in a way that would allow access for aviation use of what is a large automotive supply chain. Can you talk about, I think, one, Dana, I think awareness from your side, and then Max, a little bit more of what you see, thoughts from industry on that, and any efforts AIA's work specifically on where in government there might or might not be an appetite for that.
Well, just hopping back to the battery issue, one of the things that's heartening to see is that a lot of the vehicle or the eVTOL OEMs are building their vehicles in a modular sort of way so that when new propulsion, for example, or new batteries come along, they can swap them out without having to go back to the drawing board, right? And so I think everybody realizes that, the battery production and battery advances are going to be iterative. I mean, we like to hope that there's some quantum leap coming, but I think they're all allowing for the fact that as the new batteries come, they can swap them out for the newest thing. And also that helps because they're kind of supplier agnostic in a way too, right? So if a particular supplier goes under or there's some other reason that it's disrupted, they can move to a different cell technology without having to redesign. And so that's good thinking, right? I'm glad that they're thinking forward that way, and it's really necessary when you're dealing with technology that's evolving like this, especially when something like batteries is such a limiting factor in the performance characteristics of the vehicles. Max, if you want to take the other half of that question, sorry.
And I think this is something, as we talked about, there's obvious deltas between automotive manufacturing and aviation manufacturing and the safety and reliability. I think the FAA and PK at NASA have been very forward-leaning now in working with these types of companies, whether it be automotive or another sector, to teach and learn and have them learn more about the aviation reliability. The FAA has Center for Emerging Concepts, I believe is the title of it, under Dr. Mike Romanowski in this Policy and Innovation Division, that is really the hub for manufacturers to bring these and to see where the deltas are between where they are now and where aviation is and other places. So I think from an aviation perspective, we're doing everything we can to reach out and tell people we want them to become part of the aviation sandbox. Obviously, any technique we can leverage, we should. And obviously, can't speak to any individual designs or anything like that. But I think overall, I would say the FAA and NASA have been great partners with other industries to bring them into the aviation sandbox.
Well, Max, Dana, thanks so much. PK, appreciate you joining us here. Again, congratulations to the Joby and the Beta teams, and thank you all for joining us this afternoon. I'll look forward to having you back next week as we talk in more detail about some of the research and development where a lot of this supply chain is sprouted and where we see the biggest advances potentially coming through the cooperation that we're doing with Agility Prime and other government players. Thanks for joining us this afternoon, and we'll see you next week. Goodbye.